Welcome back, my dear students. So in the last part of the video, I think we discussed about bakelite and related polymers, that is melamine formaldehyde polymer and phenol formaldehyde polymer, and also we discussed about rubber. What is natural rubber? What is its monomer? Vulcanization of a rubber, that is addition of a sulfur to the rubber, as well as on the synthetic rubber, that is nothing but a neoprene. So in this video, we are going to discuss two concepts actually. One I am dealing with, that is a copolymerization. Okay, copolymerization, and another one I am dealing with biodegradable polymer. Biodegradable polymers. So these two I am going to discuss in this part of the video. So almost this is an end of the content, that is the polymers of your CBSE class 12. With this we almost complete. First we will discuss about copolymerization. Here you are going to discuss two different polymer. One is BuNa-N and BuNa-S. What is copolymerization actually? It is a polymerization reaction in which a mixture of more than one monomeric species is allowed to polymerize. Means more than one monomeric species. And remember, the copolymers can be made not only by chain growth polymer, but they can also be made by step growth polymerization. You can do by condensation polymerization, or you can even do by addition polymerization also. And remember, it contains multiple units of each monomer used in the same polymeric chain. So this is all about copolymerization. Then in this copolymerization, we have two methods of different polymer to be discussed. One is, we call it as BuNa-N, and another one is BuNa-S. So here first one we are discussing BuNa-N, and the second we are discussing BuNa-S. What is BuNa-N? So this is supposed to be called as, the monomers used are butadiene and acrylonitrile. Two monomers are used. So butadiene formula, very simple formula it is. Butadiene 4 carbon atom chain alkene containing a 2 double bond. I take n molecules of CH2 double bond CH, CH double bond CH2. So this is called as 1,3 butadiene, and this is made to polymerize with acrylonitrile, n molecules of CH2 double bond CHCN. You know already, ethene nitrile, that is acrylonitrile. So this is called as acrylonitrile. So what will happen? You have to join these two, so that by shifting the double bond, so this bond will shift here, then this double bond then connects to the CH2, and this double bond will go to the end. So therefore the polymerized product will be, the chain continues. What is there here? You start reading from here left to, I think this left here till this part. Up to this you have to read. So what is there? CH2, double bond will become single bond. We have a CH, double bond CH, single bond CH2, and then we have CH2, then we have a single bond CH, on the top of CH we have Cn. So the chain becomes N times. So this itself is called as BuNa-N, that is butadiene and acrylonitrile. See, it is very simple. where we take 1,3 butadiene and acrylonitrile N molecules, just shifting a double bond will become single bond will become double bond. This is the partial structure of that is Buna N. So making on to the what a major application of this Buna N and Buna S. Both are copolymerized product. They are used in manufacture of auto tires, floor tiles, footwear components and cable insulation. Majority application of this Buna N and Buna S. I think there won't be difficulty with the Buna N preparation. Now we are going with almost very important 2-mark question, preparation of a Buna N. Then we go with the Buna S, B-U-N-A, yes. What does Buna S stands for? Butadiene and styrene. Very simple molecule. Monomers are almost the same. One of the monomer is almost the same. They are using butadiene. And another monomer is styrene, that is a phenylethene. Okay, so as usual, butadiene I am writing N molecules of CH2, you know, double bond CH, single bond CH, double bond CH2, plus one more molecule, N molecules of phenylethene. So phenylethene means benzene ring, okay, connected to CH, double bond CH2. So you know this, the name of these molecules are, this is 1,3 butadiene and this is phenylethene, that is nothing but styrene. Therefore the name comes as Buna S. Here S stands for styrene. This is made to polymerize. Which polymerization? This is copolymerization. Okay, copolymerization, made to polymerize. So down, there is no space on the right side, that's why I'm writing down the partial structure of Buna S. You know how I told you to write? Look over here everyone. This double bond you are shifting here. This bond will go and attach to the CH. This double bond will go to the end. Means all double bond will become single bond and a single bond will become double bond. And you start reading from this CH2 till this end CH2. This one. You can easily visualize. Yes. Now down I am writing here. You see what is there? CH2 is there. Double bond will become single bond, that is CH. Double bond CH. Single bond CH2. This CH2 is then connected to CH. Single bond CH2 becomes N times. But remember, at the CH you have a phenyl ring attached, that is a benzene ring attached. So this is the structure of a Buna S, that is butadiene and styrene. Two different monomers that are used is 1,3 butadiene and another one is styrene. Hence the monomer polymer is also called as Buna S. Buna N and Buna S are the types of copolymerized product. So copolymerization of butadiene and styrene will give you Buna S, and copolymerization of butadiene and acrylonitrile will give you Buna N. So these are used in making auto tires, floor tiles, as I said earlier, footwear components and cable insulation also. And this is a good substitute for natural rubber, even that is also very important. You know, Buna S is a good substitute for natural rubber as it is quite tough. Now at the last we are going with the biodegradable polymer. You know, I will tell you something about very interesting biodegradable polymers. See students, a large number of polymers are quite resistant to the environmental degradation process and are thus responsible for accumulation of polymeric solid waste material. You know, that is what happens. Nowadays you might have seen polythene bags are banned. You know why? Because they never undergo chemical degradation or environmental degradation once you throw them in the soil. So these solid waste cause acute environmental problem. You know that because they remain undegraded for quite a long time. In view of this general awareness and a concern for the problem that is created by these polymeric solid waste, certain new biodegradable synthetic polymer have been designed. These polymers contain functional groups similar to those functional groups present in the biopolymers. See, so aliphatic polyesters are one of the important class of biodegradable polymer because these can be easily degraded by the microorganisms that are present in the soil. And for your syllabus, one of the biodegradable polymer that they have given is PHBV. The name of this entire long form of PHBV stands for is poly beta hydroxy butyrate co-beta hydroxy valerate. So this is a long form of your PHBV. Poly P beta hydroxy H butyrate and co again beta hydroxy valerate. So entire name is PHBV. So this poly beta hydroxy butyrate co beta hydroxy valerate is usually synthesized by taking two different monomer. One is 3-hydroxy butanoic acid. See, 3-hydroxy butanoic acid. Butanoic acid means 4 carbon atom carboxylic acid. At third position, hydroxy group is there, OH group is there. Another one is 3-hydroxy pentanoic acid. Pentanoic acid means 5 carbon atom carboxylic acid. At third carbon atom, we have as usual OH group attached. So I am writing the preparation of this PHBV, which is quite important, 2-mark question. Write the preparation of PHBV. So 3-beta hydroxy, that is butanoic acid, I am writing as usual OH group attached to CH, CH3, CH2, C double bond OH. So this we will take N molecules. Here you should notice this is carbon number 1, this is carbon number 2, this is now carbon number 3, this is carbon number 4. It is a butanoic acid. Please highlight here 3 carbon atom, third carbon atom, there is a presence of OH group. Therefore 3-hydroxy butanoic acid written. Now I am taking N molecules of 3-hydroxy pentanoic acid. Here also OH, CH, CH2, CH3, CH2, C double bond OH. Here also you can notice this is carbon number 1, this is 2, this is 3, this is 4 and this is 5. At third carbon atom we have a OH group. So when this is condensation polymerization we do. So when this is polymerized, you have to notice here from here H and this OH together eliminates as H2O, and similarly here also H and this OH both will eliminate as H2O, and remaining we have to write the product, that is the structure of PHBV. So now you tell me, if H goes here, what is left out? O. That O connected to CH, down you have a CH3, then we have a CH2, then we have C double bond O only because OH gone. I think this OH gone. Then what is there? This C double bond O, then connects to this oxygen because here hydrogen gone. So we have a O, then we have a CH, down we have CH2, CH3, then we have a CH2, then we have C double bond O, there also OH gone, makes it N times. This is the partial structure of your polyhydroxy butyrate co-beta hydroxy valerate, that is PHBV. So this is how you need to memorize or you need to remember the structure of PHBV. It is a long molecule. If you miss the carbon atom, entire thing will go wrong. So that's why 2 different monomers are used, students. One is 3-hydroxy butanoic acid and 3-hydroxy pentanoic acid. So this is all about biodegradable polymer, and this is where major application of this is used also in NEET competitive examination. So this is the question that has been asked many times, that you have to remember. This PHBV you are using controlled release of the drugs. I think the capsules whatever we take which is coated with a plastic material outside, that we call it as a controlled release of the drug, and also used in orthopedic devices. That is very important, that in the board question also this is was asked as students. The polymer which is used in making orthopedic devices, special packaging materials, that all are controlled release of the drugs that we are using, PHBV, this one. So this is used in control release of the drugs and orthopedic devices, and also in special packaging materials. So this is all about pH, BV. So with this, I think we conclude the entire polymer lesson. I think previous videos we have, if you have not watched, then please watch them. So we have a part wise video, part 1, part 2, part 3, part 4, and maybe the part 5. So with this, we conclude the polymer content. So thank you for watching the video, students. Thank you very much.